When we write a fraction, we do not like having any irrational square roots in the denominator, and if we find any, we are tasked with getting rid of them, a process called rationalising the denominator. The first case we'll look at is when the denominator contains one term with an irrational square root, say 7 over root 5. To manipulate a fraction without changing it, we must only multiply top and bottom by the same thing, since this is the same as multiplying by 1. The number we're going to use to multiply the denominator and the numerator here is going to be root 5. Multiplying the top by root 5 simply gives us 7 times root 5, whilst multiplying the bottom by root 5 results in 5. Our denominator now contains no square roots and so is rationalised. The second case is when the denominator contains two terms, with one or both of them containing irrational square roots. For example, 3 over 5 plus root 2. What happens if we try what we did in the first case and multiply top and bottom of this fraction by the irrational denominator? The numerator expands out to this, while the denominator expands out to this. We still have a square root term, and so the denominator has not been rationalised. The solution to this problem exploits the following fact, that for any two numbers, a and b, a plus b times a minus b is a squared minus b squared. This is easily seen by expanding out brackets. The positive and negative ab terms cancel. For this reason, we choose to multiply the top and the bottom not by 5 plus root 2, but 5 minus root 2. The numerator now looks like this, and since the denominator is now 5 plus root 2 times 5 minus root 2, it can be written as 5 squared minus root 2 squared, or 25 minus 2, or 23. This denominator is now rationalised.